Good morning, this is your Stat Sensei, Mr. Spensei, and this is binomial distribution classwork 3B.1, and it's problems 3 through 7. So a fair die has four faces numbered 1 to 4. So basically that means I could get a 1, a 2, a 3, or 4. What's the probability of rolling a 2? Well, the probability of rolling a 2 happens to be 1 out of 4, which is 0.25, which is where that came from. Q is the probability of not rolling a 4. So 1 minus 0.25, which is 3 out of 4, which is 1, 2, 3 out of 4. Okay? So what's the probability of rolling a 2 exactly 3 times in 10 rolls? So how many times are we doing something? Oh, we're doing it 10 times. So we make a number line where we number 0 to 10, but we want to do it exactly 3. Well, I'm only circling one value, but I have a specific number of trials. So my number of trials is 10. My probability for that is 0.25. And we want X to equal exactly 3. So that's my X value. So this is going to be 10 choose 3, 0.25 to the third, 1 minus 0.25. Now, please remember, this is going to be 10 minus the 3. So that's what I'm going to show for my work. Let's go ahead and work this out on the calculator, and then we'll fill everything in. So second vars, binomial, PDF, trials, 10, probability of a of getting a 2, 1 divided by 4, which I could have just put in as 0.25. And my X value, I want 3 successes. And I get 0.25028. There's my calculator commands. Now, I want to point out some things to you again. I cannot stress this enough. This is my X value. Here it shows up here. Here it shows up there. And it's also hidden right here because this is 10 minus 3. And so that 7 came from the 10 minus 3, which is right there. The next one, find the standard deviation and expected number of threes for 10 rolls. Okay, we still have the same number of trials. We have the same probability. And Q is, remember, Q is just 1 minus P. So this is 1 minus 0.25 equals the 0.75. Well, expected value is NP. So 10 times 0.25 is 2.5. Plugging in, and this is what we get. Once again, I like to show this just because I want you to get good at it. 10 parenthesis 0.25 and 0.75. And then I raise that using this button right here to the 0.5. And I get 1.3693. What's the probability of rolling the die 20 times and getting no more than 3 4s? So I need to make a number line all the way to 20 because now my sample size is 20. And I could have no more than 3. So I could have 0, 1, 2, or 3. And I should remind ourselves when we're rolling the dice, we have 1, 2, 3, and a 4. The probability of a 4 is 1 out of 4 or 0.25. So that's why that's that same probability, even though we're not rolling 2s anymore. So this case, we're dealing with a summation because we have multiple values. So anytime you have multiple values circled, you're working with a summation. So we start off by going pressing the math button, scrolling down to summation. X, which means I need to push the XTON button, which is right here. All right. Now we wanted 0, that's my lowest value, so that's what goes here. So this is going to be a 0. Arrow up. My highest value I wanted was a 3. Need to press clear there. There we go. So 0 to 3. Arrow over. And this is where we're going to act like it's a regular binomial. We'll go second vars. Binomial. PDF. Trials. In this case, we have 20 of them. That's what we wrote. Probability of success is still the same, but our X value we need to change to X, which is the XTON button. and we get 0.2251. Okay, so there's our answer. Now for my work shown, please remember, this is 0, 0, 0, and you got to remember that this 20 is not just a 20, it's actually 20 minus 0. And then we have our higher value. Our higher value is 3. And there it shows up again. And remember, it's also hidden right here because this is 20 minus 3, which gives me that 17. And my lower value was 0. My higher value was 3. Okay, continuing on. A packet of carrot seeds has a germination rate of 92%. In other words, the probability of any seed sprouting is 92%. So 92% sprout, 1 minus that gives me my failure, 8% don't sprout. How many seedlings would you expect in a row of 50 seeds? Keyword is expected. That means I have the expected value equals NP. Well, my sample or my trials is 50. My probability is 0.92. So 50 times 0.92, we get that. What's the probability that exactly 4 seeds did not sprout? First off, 4 out, and this is 4 out of the 50. So we have a number line to 50. We want exactly, so that makes this a binomial PDF. This is not a summation because we only have one value. Well, the probability of sprouting, excuse me, I said that wrong. The number of trials is 50. Our probability is 0.08. X is 4. Now, we're going to have to act like this is a P. Okay? So 50 choose 4, 0.08 to the 4th, 1 minus 0.08 to the 50 minus 4. That would be our work shown. So let's go ahead and run this thing. So once again, blue vars, binomial PDF, and we have 50 seeds, 0.08, and we want 4 not to sprout. So we get 0.0236. All right, and there's our formula, our number of trials, probability of success, which came right here. Please remember, this shows here, here, here. And where did that 46 come from? That 46 came from 50 minus 4. Okay, moving on. Number 5. 21% of the bolts produced by a machine are defective. Out of 6 bolts chosen at random, what's the probability that 2 are defective? So 21% are defective. So there's our probability. We have a group of 6. So there it is. And what's probability that 2? This is an exact value. So the fact that this is an exact value tells me it's going to be a binomial PDF. I only circled one value. I'm going to go ahead and label this as a binomial PDF. It's not a summation because we didn't circle multiple values. Well, if that's the case, we're just going to use this formula and we're going to go 6, choose 2, 0.212, 1 minus that, etc. So let's go ahead and drop that into the calculator. So we're going to press blue, then vars, binomial PDF, 6, probability of 0.21, x is 4, or excuse me, x is 2 defective, and we get 0.257. So let's look at this once again. Let's see where that value goes. 0.2, 0.2, and 2, 2, and then this is 6 minus 2. That's where that 4 came from. Okay, number 6. Statistical data indicates that 35% of all persons who are afflicted by a certain disease recover. What's the probability that 9 out of 10 patients recover? So in this case, we have a group of 10 and we want 9 successes, exactly 9. So we're going to go have a number line 0 to 10, but we want exactly 9. The fact that we have only one value tells me this is a binomial PDF. I do not have to use a summation. So we have 10, probability is 35%. We want exactly 9. So this is going to be 10, 10 choose 9, 0.35 to the ninth, 1 minus p, and this is 10 minus 9. So real quickly, let's mark our important stuff. Or let's go ahead and run this first, actually, since I like doing that. Blue bars, binomial, PDF. Trials in this case was 10. Probability is 0.35. And we need 9 people to recover. And we get this. So, oh, and by the way, I should make a comment. You see that? Change the number by 1, and I mean, so we, instead of a -4, make it a -3. That's how many zeros you need in front. So that's why it's 1 less. So 1, 2, 3 zeros in front. So you should be writing this as 0005. Okay, technically 005, 1, 2, 3, but we don't worry about that. We only need 4 decimal places right there. Okay, now the important thing I always want to point out, this is a 9, this is a 9, this is a 9, and that 1 came from 10 minus 9. Okay, number 7. There are 156 candidates taking a course. The probability a candidate passes is 0.73. Find the probability that 2 out of 3 candidates chosen at random pass the course. So we have a group. We have a group of 3, and the probability of 2 out of the 3 candidates. So exactly 2. So we're only circling. By the way, this should not have gone to 4, 5, 6. This should have been to so this right here, we don't need this part right here. This is just a 2. And this 156 is confusing, but it's 2 out of 3. So we randomly selected 3. So we have a group of 3. We have to be careful about that. That 156, that's a distractor. That's the entire population, but we have a group of 3. So 3, probability 0.73, what's the probability of X? So let's go ahead and run this thing. Blue vars binomial PDF. Trials in this case is 3. Probability is 0.73. X value is 2. And we're 0.4316. All right. I hope, oh, and I should point out the thing again. This is 2. This is 2. That's 2. That's where that all comes from. You get that X value that comes from here. Because remember, that's just this. And this is 3 minus 2. That 3 minus 2 is what gives me this 1. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.